Hey everyone, I'm launching this channel, Code Free Future AI, to share the honest, self-taught path to mastering artificial intelligence. But let me be clear, this is not a success story, yet. 6 months ago, I made a life-changing decision to dive into the world of AI. I went all in. I bought a powerful new laptop and a full stack of online courses. But here's the truth. I bought them and I did nothing. I started just one course, and I quit halfway through. Fear, procrastination, or maybe a fundamentally flawed approach, it was all there. My initial investment was an MSI laptop, specs, an i5 processor, RTX 4050 graphics card, 16 GB of RAM, and a 1 TB M2 SSD. I thought I was making a strong start, but I quickly learned that for serious AI work, this setup was insufficient. High performance, speed, and large model development demand a desktop PC. Here are the minimum requirements for an ideal AI build, based on my mistakes. 1. The GPU. You need a card with at least 12 GB of VRAM. I strongly recommend NVIDIA's RTX 40 or 50 series. Why? Because AI is heavily optimized to run on NVIDIA's Tensor and CUDA cores. The AMD versus NVIDIA reality. When comparing an AMD card to an NVIDIA card with the same VRAM capacity, say 16 GB, NVIDIA is far superior in AI training stability and performance. Almost all major AI libraries like PyTorch and TensorFlow are optimized for the NVIDIA ecosystem. This creates an incredible performance gap right from the start. Ideally, an RTX 5090 would be phenomenal. 2. The processor. CPU. Look for an Intel i9 or AMD Ryzen 9 series. The key metric here is high core count. This is vital for managing parallel workloads and feeding the GPU with data, which is the second factor preventing bottlenecks. 3. The RAM. A minimum of 32 GB is essential. However, I aim for over 100 GB for future large AI models. Crucially, when the GPU runs out of VRAM, the system starts using the RAM as a buffer. We need high RAM capacity to avoid the major bottleneck issues that cripple performance. Also, if installing multiple RAM sticks, ensure they are the same brand, model, and capacity. 4. Storage and motherboard. You need at least a 1 TB M2 SSD and additional storage. The motherboard must support future upgrades with ample PCIe lanes and multiple NVMe M2 slots to handle these components. 5. Cooling and optimization. AI tasks generate extreme heat. Therefore, extra case coolers and a well-ventilated case are a must. High heat degrades performance and shortens component life. Low-capacity PCs can run AI, yes. But this high-capacity hardware tends to create a massive leap in speed, performance, and developmental capability. My first mistake was miscalculating that difference. Now let's talk about the courses. I bought a ton of traditional coding classes, but honestly, I still can't code. I miscalculated the learning path. I wasted a lot of time on traditional courses. If I could start over, I would choose courses that focus only on AI concepts and math fundamentals, not on forcing me to write basic Python. My goal should have been understanding the logic of AI, not becoming a generic developer. So, how am I still working on complex AI concepts, entirely with ChatGPT? I am not writing code. I am making AI write the code. I am learning AI by working with AI. I am not school-taught, but self-taught, or maybe you can call me AI-taught. My job is setting up environments, identifying problems, and giving ChatGPT the perfect prompts to generate the solutions. This approach defines the new career path of the AI era. I'm going to be a prompt engineer, not a traditional developer. That's why this channel's roadmap focuses only on prompt engineering, running code with ChatGPT's help, and understanding core deep learning concepts. If you want to master AI without the burden of traditional coding, this self-taught journey is for you. Type prompt in the comments below and subscribe. See you in the next video.